say you have a collection of text documents. Now, typically, one of the first tasks is to organize them. But how? Well, we probably want to find some groups of similar documents, and then we can see how those groups differ. This kind of analysis is called clustering. So we will start with a dataset of 44 stories written by the brothers Grimm. We can get them directly from the preloaded example datasets in the corpus widget. The same widget we use to define which features contain the content we're interested in and where the titles are. Now, as this is already preset for the Grimm tales, we can simply move on. So the next step is to pass our data through the preprocessed text widget. Along with the default settings, we'll add in an additional normalization step. This will transform the words to their base form. Also, take care to place the normalization step after tokenization and before filtering. Okay, now we can pass our preprocessed data to the bag of words widget and also use the TF-IDF transformation. The bag of words widget represents our documents with the number of occurrences of each word, and TF-IDF normalizes those counts so that the words that appear in too many documents have a smaller weight. Okay, with this vector-based representation, our set of documents is ready for clustering. First, we need to compute how similar the documents are to one another, and we can do this using the distances widget. But instead of plain Euclidean distance, which fails for so many features, we'll use the cosine distance. Now, cosine distance measures the cosine of the angle between two vectors, focusing on their direction rather than their magnitude. Unlike Euclidean distance, which can be skewed by document length, cosine distance indirectly normalizes word occurrences. This makes it more effective in text mining, as it accounts for the relative frequency of words rather than their absolute counts when comparing documents of varying lengths. Now, let's pass the computed distances to hierarchical clustering. We find one group of tales of magic and another group of animal tales. But there is some mix-up. 2 tales of magic made it into the group of animal tales. So let's try to figure out why. We can select the confounding group and pass it over to word enrichment. This widget will identify the words that are significantly more represented in the selection compared to the entire dataset. So the widget has 2 inputs. First, the data subset, and second, the entire data from the bag of words. Now, finally, we can change some of the settings. We want to uncheck the FDR option and select the p-value. Our dataset is fairly small, so FDR won't be very useful, but the p-values still might be. Now, let's see. Our mixed class group is defined by the words wolf, fox, and snore. Now let's take a look at the 2 tales of magic that appear to be animal tales. Little Red Riding Hood, there's definitely a wolf in that one. And while it is technically a tale of magic, it contains some elements of animal tales as well. So the clustering was, in a way, correct. Now, what about the group of tales that includes the Frog Prince, Cinderella, and the White Snake? Well, this group is a bit more complex, but it's characterized with some words like princess, queen, king, gold, and horse. All of these words are words that you would expect in tales of magic. So document clustering is a great way of finding similar documents, and word enrichment can help us explain these clusters. Of course, hierarchical clustering is not the only clustering technique. For more on clustering, you can take a look at some of our other videos from the Introduction to Data Science series. Until next time.